And we are live on this second edition of Why Do They Keep Letting Me Run This One?
Ben's a good sport.
I'm going to get too good at this, and then I'm not going to let anyone else do it. I'm going to start
What
doing
shape
it
are
all
you
in
around the
detail.
office?
Welcome to Cloud Foundry 101. Yeah, all right. Well, we have a special guest this evening, Dimitri, who
Hey.
owns all things Bosh, and is here to talk about some exciting new developments in Bosh. And then I believe you can expect an hour of the usual inanity.
Yeah, I think so. I'm just tweeting out, join CFAT tonight and talk Bosh. It's special to have Dimitri on.
Yeah, good job.
He's normally too busy in the office at 875 actually working.
No, it's fine. I just tweeted about myself.
I am in the office. That is true.
Are you in the office?
Yep.
That's a spring beanbag, isn't it?
It is.
Yeah, that's a spring source beanbag. Now I recognize it.
Yeah. Don't have bags at home.
That's where we get together on Sunday nights and hang out and talk about all things Cloud Foundry. And for people who don't know Dimitri, he is one of the leading engineers on Cloud Foundry who then was an engineer on Bosh and now is converted to being a Bosh product lead and has set out a pretty ambitious roadmap for Bosh. And it's actually one of the areas that Pivotal is making some of our biggest human resources investment on the engineering front right now in terms of ramping up things. So I thought it'd be awesome if Dimitri came on and shared some ideas about where he wants to go over the next 6 months to a year.
Yep. Yep. How many people we got now on Bosh? Too many.
As many as you can handle is the rule, right? We're like, just keep feeding him till he says no, no more.
For now it's all good. Keep on adding.
Yeah, yeah.
So what do you guys want to talk about, or to start off, I guess? Can talk about, I guess, some of the stuff that we already worked on and kind of finished. Yeah, so we've learned a lot from Ops Manager adventures for the past year or so. For features, for example, first-class availability zones and dealing with all of the selection of different resource sizings and things like that. And I guess one of our goals is to move majority of the stuff into Bosh to make it more user-friendly and at the same time to be able to be closer to where the actual stuff happens as opposed to having some other tool drive out all of this stuff.
So maybe, Dimitri, you could explain for people that might not know what Ops Manager is. You worked on that project, what Bosh is.
Sure.
Just the distinction between the two.
Well, Bosh is the tool that deploys pretty much everything at Pivotal. One of the things that it does is it deals with the infrastructure and provision the VMs and other resources like disks. It also keeps updated software on all of those VMs, and when it's necessary, it deletes or recreates or resizes those VMs to appropriate sizes and moves the data around in a fairly efficient way. Ops Manager, we've started. When did we start on Ops Manager? Probably a year and a half ago, maybe a year ago. Is more or less a UI for Bosh, but it drives out more high-level features of Bosh, like what we have is called tiles. Tiles typically just contain the software as releases, and they also contain the stem cells. Both of those things are first-class Bosh concepts, but we package them up together in tiles so that it's easier for customers to install the software. And so far, Ops Manager has been pretty much the UI on top of Bosh and drives out Bosh functionality as normal user would through the CLI. But in Ops Manager, you just click on the apply button and you end up with the Bosh deploy happening in the background.
Yeah, so for people who haven't used it, maybe I think when you get into some of these concepts of what we're adding to Bosh from Ops Manager, like pulling it from what we did in closed source experimentally into that, it's good for people to understand that at the end of the day, Ops Manager generates a big YAML file that is one of the things it does that helps it configure things.
Right.
Maybe you want to talk a little bit about what those do.
Sure. Yeah. Today, the primary configuration, I guess, API for Bosh is through the manifest, right? The operator defines all kinds of different things in the manifest, like for example, the resource sizing, the different layout, the topology of your deployment. Lays out what kind of software to install in that deployment, versioning of that software, and what kind of OS to use for those VMs when it spins them up. And a lot of that stuff is just described today as a single deployment manifest. It's fairly lengthy file, gets for specific deployments. Cloud Foundry file is fairly long, and some of that stuff is somewhat repetitive. Some of that stuff is is necessary to be described. And so far, Ops Manager has been the thing that actually generates those files and just passes it down to Bosh so that Bosh can actually act on the changes that Ops Manager decides to make to the deployments. And a lot of these manifest changes really come from the UI that is configured by the users, or actually the values entered into the UI by the users. So resource sizing, the number of instances, how AZs should be split, or not split, but how the jobs should be split across the AZs, and how big are the disk sizes and things like that.
Yeah.
So all that stuff really goes into the deployment manifests.
So I think, just this is like the Bosh Crash Course 101, but it's pretty unique in that it combines the functionality of something that embeds sort of a JEOS, something like RightScale-like that uses infrastructure APIs to go provision infrastructure. It updates itself. It versions deployments that have been dropped down, and it really doesn't like configuration drift either. Like, so if you try to take something out of config, it's sort of like it would just proceed to put it back into config. And it's a pretty unique tool.
Right. Yeah, I think it's one of those tools that combines everything together in a very specific way, as opposed to trying to build up onto very many little tools, which has its own advantages. We do definitely get a benefit of knowing exactly how things are deployed down to the OS level and which kernel is running and so on. But that's Bosh does operate on the whole stack from the VM and up, and is responsible for figuring out how to update it and how to stop things and restart things, which definitely deals a lot with puts the work to figure out all of those things on the release authors, who are the ones who are making those releases, and not on the operators who have to just figure out, hey, which versions should I use, and that's it. So a lot of that burden is shifted towards people who are actually making the releases, as opposed to on people who are operating those releases in production.
I think a great example of this is the kernel issue that came out just this last week, right, Dimitri, where we had to do a kernel update because of I think it was a vulnerability in ping.
Right.
And so basically we turned the crank on a Bosh dumb shell, which updated to the latest Ubuntu 3.16 kernel, and we were able to deploy that in production really straightforwardly by changing probably a couple of lines in this manifest you're talking about to point to the new stem cell. And Bosh takes care of all of that automated updates to our production system. And it was just it's such a non-event now. Like, we do all these production updates during the day, during business hours, while everyone's at work. And because of the way Bosh does the updates, it just takes a couple of VMs at a time out of commission, and then spins up new VMs to replace it with the new kernel, and then rolls through the whole cluster, and the whole system stays available the whole time. So it's a pretty powerful tool for doing day 2 operations, where a lot of these other tools that people use for ops, put some of that burden on the administrators themselves to kind of perform checklists and manual steps or write scripts to do these things. But Bosh kind of has that automation built into it just via opinionated software.
And those are good points, James. The common question we hear when we speak in the enterprise is guys who've been using like the traditional CF tools, CF management tools, like Chef and Puppet and Ansible and SaltStack, and they start to scratch their head. And the smart ones who look at Bosh for the first time, it just blows their mind on what it can do. Like the day two stuff you spoke about, the canary style upgrades that happen, that's like burnt intrinsic in the platform. The fact that I'm not writing, I'm decoupling the underlying infrastructure from my upper layers, whatever it is. It could be Cloud Foundry, maybe something else that you're building. So I can build Bosh scripts that can span across multiple clouds or multiple infrastructures. So I don't know if Dimitri wanted to expand a little bit more. I'm sure you played with a bunch of the CF management tools, but it takes a little bit of time for people to get it. But once they get it, they never get back. But it's that initial part that it has people head scratching. So what has been your experience? I don't know how much you played with the traditional CF management tools.
Well, I mean, Bosh really did come out of frustration of using tools like Chef for managing Cloud Foundry, right? It covers the IaaS and the software installation operations, right? And by combining the two into a single tool, you're actually able to more easily reason about, hey, how do I update the whole cluster to a very specific point, rather than trying to deal with, hey, there's a bunch of servers, let me write some, or let me run some tooling that updates this bunch of servers, and then when you actually have to, throw away the servers and get over to the new ones, you have to now manage that yourself manually, or maybe with some other, tool that you have to deal with now. So yeah, Bosh does have a fairly steep learning curve, which we're trying to, improve and lessen. There is some of the features that I guess we'll be discussing today will help out with that. But once people get hang of using Bosh for their production environments, they typically don't try to think about how to deal with the underlying VMs and the software installed separately from installing the software on top of them.
Yeah,
the way Bosh does it.
Yeah, great point. I mean, as you start to see the last couple of years, the dramatic rise in distributed systems, and you're not provisioning one system at a time, which is like great for Chef and Puppet. But if the software you're trying to provision is still distributed, right? Cloud Foundry itself being a classic use case, but almost everything that's going to be built going forward, if it's not distributed native, there's something wrong with it, right? You can't do distributed. Version 1.0 can be static, and then you can't just go say, I'm going to build version 2.0 as distributed. You can't do that. So for distributed native products or software, I can't imagine any other tool that can do it with the ease with which Bosh can do it, because it's inherently designed to support those kind of things out of the box. Granted, the learning curve is high. We're looking at ways in which we can lower it. But trying to hack through deploying a distributed system using traditional CF tools is just a nightmare, at least from my experience.
Yeah, I agree.
So Dimitri, maybe you should talk a little bit about some of those features that we've been working on, specifically the things that a couple that you mentioned already is like putting some of the stuff around the IaaS configuration into a centralized configuration file instead of repeating that in the manifest, and then the availability zone, first class availability zone support. You want to talk about those?
Sure. So yeah, one of the I guess lessons that we learned from working on with Ops Manager is that it seems like it makes sense to aggregate all of the IaaS configuration in one place, as opposed to trying to make it configurable in per deployment effectively, per collection of your resources, which is something that, I mean, we'll see how that works out in practice with more and more projects switching to that. But one of the features that we recently introduced is cloud config, what we call it. It hasn't been really publicized yet, just because we're still finishing up some other related features for it. But the idea behind it is today all of the manifest specific to Cloud Foundry, let's say, or manifest specific to MySQL service or some other service, they typically include sections that describe the VM and disk sizing and configurations for their IaaS. And that's somewhat inconvenient to carry those manifests over to different IaaSes because these little tiny bits of information change. So there's some additional tooling that people try to use to combine those two configurations into effectively one file. And we don't necessarily think that they need to be in one file. So what we've done is we separated this information into a separate configuration that you do once per your Bosh directory. So once you configure a Bosh directory with VM sizing, with disk sizing, with networking configuration, you're able to now reference that information in deployments. That way you don't have to repeat yourself in each one of the deployments. That way you also can share the same configurations resources more easily. And also for networking specifically, it simplifies a lot of the mappings that today people typically have to think about a little bit more, than rather just saying, hey, I want to be on network A versus network B. So that's something that we call cloud config. And that's, we're currently working on this thing called also global networking. That's the thing that will allow simplification of how Bosh puts, how Bosh uses which network for which VMs. And that's actually a fairly big change in Bosh in terms of simplification of how the system deals with it, but it does tremendously simplify the user experience.
Yeah, so Dimitri, I think one of the things that'd be good to tell people is one of the use cases that drove the networking simplification was the desire to have a on-demand provisioning of new clusters as needed without the service broker having a huge mapping of networks that it could use, etc. Do you want to go into a little bit of that use case and why we derived at needing this feature?
Sure. So I guess maybe as a little tiny introduction, what really happens today is when you configure a deployment on a specific network, on a specific subnet, you effectively telling Bosh, hey, go ahead and use this subnet for all of the VMs that you're going to create. And you may also have in other deployments that want to potentially use that same subnet just so that you don't have to just because you've decided that's how you want your network to look like, which is fairly common scenario, right? Some people prefer to create separate subnets per specific deployment, but other people just prefer to put everything in one subnet and maybe use some other ways of separating things out, like security groups or something like that. And with where we're going right now, right, is Bosh is simplifying Bosh to a point where for service brokers it's very easy to create these deployments and manage a service dedicated service instances, right? Which means that Bosh will have to handle a lot of these deployments probably on the same network. And without this simplification, that would mean that service brokers would actually have to do some extra mapping that Bosh in theory should be doing in terms of where to place the VMs. So that's a lot of information and just knowledge that service brokers shouldn't even have to do and know about. So that's partly why we would want to make this change. I mean, and as a beautiful side effect here, it definitely simplifies the initial user's experience and how to use Bosh with multiple deployments without making them go through hoops and configure separate networks for lots of different things and figure out different IP mappings and overlaps and things like that. So that's a short explanation for this feature, I guess.
I think James has the presentation Unsi made or you and Unsi made up, showing a little bit of. James, is that you?
Yeah. So let me pull this up here a little bit, and I can actually. There's a pretty nice presentation that I won't spend a lot of time on it, but it just visualizes the things Dimitri's talking about. So in this case of services where we want on-demand provisioning, you have the service broker, and someone says, hey, give me some VMs, and you give them some VMs, and then someone else comes along. Well, first of all, it's not just as easy as give me some VMs. Like, you want to put them in different AZs. In Amazon, that's the classic AZ that they have, but in vSphere, that's separating things on vSphere clusters and resource pools and things like that. And then you have to do the IP assignment, and then someone else comes along and says, well, I want some other VMs, but I want them to be a little bit different. And it's just a lot of information to hold in your head and write in this manifest. So what that looks like is at the end of it, this is this long manifest that Dimitri was referring to. A lot of information there about your network. Your IaaS information is with the current Bosh manifest has it all. Your machine sizes, your AZs, and things all mixed in together. And where we're going with this is to kind of take that stuff that's IaaS specific and take it out. So all the stuff in red is gonna move out, and all the stuff in blue that's specific to your deployment is gonna stay. And so you can see there's a lot of red and not a lot of blue. And so what we're left with is a description that lets you take all that stuff in red and put that in one place. And so this is showing how we're separating that out. We're going to move all that do not repeat yourself stuff into one file that describes the network, the AZs that we want, and the size of the instance types. And now the job manifests themselves that describe a deployment are much simpler. You see that on the right-hand side. So now they don't have IaaS-specific stuff in them. We still have this concept of availability zones, but that's going to map onto the concept that's specific to that IaaS. It's more of a Bosh concept that then kind of bleeds through, as opposed to having to put a bunch of IaaS-specific stuff in the manifest. So that manifest on the right-hand side should be about the same between AWS and vSphere and OpenStack. There's really not much different at all, which is very different than where Bosh has been in the last couple of years, where if you looked at a Bosh deployment, the one that went to OpenStack versus one that went to vSphere, for example, they would have lots of visible differences, and in this one, now they don't.
So one way of saying this, maybe for the people that haven't done a lot of hands-on keyboard time with it, is Bosh used to be very feasible to work across clouds. It had the cloud provider interface library that would allow it to automate different clouds. But there were a lot of manifest changes when you move between the clouds that should now be more abstracted, and you can have a more abstract concept like a job, and Bosh will be even more sort of natively multi-cloud versus manifest change driven.
Yeah, and it's a lot easier for that thing on the right, those 8 lines or whatever they are, to be managed by something that's doing something on demand and with automation. The Bosh deployment manifest, we built software to write it, but it was somewhat complicated software due to the size of the manifest and all the checking and validations we had to do. And to do the stuff on the right-hand side is just so easy to grasp that it's going to be very trivial to automate Bosh once we're done with all this work.
Here's Gwen jumping in with a popular topic here. Gwen is the ex-architect at Rakuten who is now works for Pivotal in Japan. Please give Bosh a real API.
Very popular question. That's a real API, though we don't necessarily claim to support it. I think once we pull in the first class AZ feature, I think we will start be more concrete about supporting the API that we already have.
Yeah, Dimitri, well, maybe you should explain that a little bit. Like, how do people interface with Bosh today if it doesn't have an API?
Fair enough. So my recommendation to everyone really is always pretty much use Bosh CLI. It has some of that, extra stuff that it does before calling out to the APIs. For example, it tries to do some validations that will be, quickly returned with the error or not, or for example, it tries to do some repacking for the releases to be more efficient and transferring the bits or not. But ultimately, it still uses the API. Most of the automation that people do with Bosh, is they just have a little script that calls out, Bosh upload this, Bosh upload that, stem cells releases, and then effectively just do Bosh deploy with a manifest, right? So majority of people, they don't really need the API. There's definitely some use cases where an API, an official supported API is needed, and that's the group of people who is always wondering how stable is the main Bosh API that the CLI uses. And I guess to answer that question, it's stable. It hasn't changed really at all. We're not planning to, break it. We still maintain comparability for the CLI itself, but we just don't advertise it so that a lot of people don't try to use it instead of trying to first use the CLI and seeing if it fits their use case. Yeah, that's there is actually one interesting question that popped up a few times in past weeks is there any clients for that API, even though it's private? And for Go, for example, there isn't one. But for Ruby, the CLI has like a director client that talks to that API. So eventually, I guess I could see us writing up an official Go client as maybe in future when we migrate to something like Go for the CLI to speed things up. So.
I know Dr. Nick wrote an experimental API for Go for Bosh, but yeah. So I know that at least someone has at least partially tried. I don't know how successful he was. So Dimitri, what else do you have planned? So you got the config management stuff through the team's backlog already, and now I think you guys are working on the IP management so that it can be much simpler to work with IPs. What else is next after that?
Right. So once we finish this global networking adventure, we're going to be working on adding this feature called links. Links allow you to specify the relationships between the jobs that get deployed on the VMs in a more or less repetitive manner. Currently, some of the burden that falls onto people who use Bosh is to configure the jobs to talk to each other. And typically, operators have to specify in the manifest how that should be done. And that's something that we've seen not a lot of people like. And it's also a lot of the times more or less useless to specify, as opposed to having the release authors do that once for the operators, and then operators not even knowing about this relationship between the jobs. So this linking introduces a concept for the release authors to take advantage of, where they can say that, hey, this job A needs to talk to job B. So for example, a Rails app can talk to a database. And all the information needed for the connection is shared through the director, and that's laid out without operators' visibility at all. So that means that operators has to deal less with generating passwords. That means that operator has to deal less with figuring out where which IP is what, or even DNS names. So it's less configuration for the operator because it's taken care of by the Bosh. That's one of the features. And I think
you mentioned passwords. That made me think of we've had people ask for Bosh to integrate with their own identity provider. I know we've got some work going on there. Maybe you could talk about that a little bit too.
The UA work, I'm assuming you're talking about?
Yes.
Yeah, we've been working actually for the past few weeks. We've resumed the UA work. The idea behind this is that Director has a very simple but yet another users management functionality in it. So we're trying to remove it and enhance it by integrating with UA. So for example, when the director is deployed on the VM, to log into that actual director, you would actually enter your configured username and password for the UA. Or if your UA is integrating with the LDAP or some other system, you'll be able to authenticate based on that, which is something that is useful for a lot of enterprise customers. since they don't want to be managing separate set of users for their own, for the directors. But we are still actually planning to keep a very simplistic functionality for those initial set of users that don't want to deal with UA and the more complex configuration where the directory would just be configured with a static list of users and passwords so that people can still log in. But I could definitely see us, we're already starting to talk about some of these details where we're able to take advantage of OAuth scopes that UA provides and map some of the objects and resources in the Bosh director to only specific users. So that would limit a lot of the visibility for different kinds of operators. Some operators might want to deal with this deployment, whereas other operators might want to deal with some other types of deployments. So that's the UA work. We're planning to actually getting very close to the end of the backlog, and then once that's done, UA team will be helping us out to, or actually will be helping the UA team out to produce an official UA release, and that UA release would be able to be used with Bosh without pulling in the whole CF. So that's the update for the UA work.
Yeah, that's something we've heard a lot from enterprise customers, that their operations teams, they just like anyone else, they have new people joining and leaving those teams, and they want to make sure they're doing their own hygiene on their user management to make sure that only the people can access Bosh that should be able to, and then if someone leaves the company, they lose access immediately, and those kinds of things. And integrating in with their SAML providers and LDAP will ensure that they can just use that centralized source of identity, and Bosh can recognize that very easily. Cool. I don't know, I've been monopolizing some of the Q&A with Dmitry. I wonder if there's other things people want to talk about with respect to Bosh.
I mean, one thing I'm really excited about, I think, James, you alluded to it, but I don't know if you spend more time. Maybe the presentation you were showing has that, but is the dynamic provisioning of services. I don't know if you spent a lot of time on this. I may have missed that in this talk. But if not, I think the fact that I, as a dev, when I do a CF create, whatever service I want to create, before I would get a slice of an existing cluster, but now when dynamic provisioning in Bosh gets enabled, I can get a full-blown dedicated, whatever instance. Could be a Cassandra or a MySQL or whatever it is. I can get my own instance. And I know that in the past, some of them have worked around by kind of working through the service broker, but when Bosh natively supports this, and with the service broker recently implementing the async stuff, I think combined with those two, or even without that, just the fact that I can dynamically provision clusters is just so powerful. I don't know if Dmitry wanted to speak a little bit more about that. Some of the use cases we are seeing around that.
Right, so a lot of the features that are being implemented in Bosh right now are just to simplify that use case scenario where we want the dev to ask the CF, hey, give me a dedicated service instance of whatever service operator has configured, and then the service broker picking up that call from the cloud controller, right? And then taking advantage of async provisioning, hopefully, and then calling out to Bosh saying, hey, here's a simple manifest with whatever configuration the service broker is able to configure it, and then kicking off the deployment. And given that with the addition of cloud config, first-class AZs, linking, and global networking for service brokers, it will be very, very easy to keep these things off and actually create this new deployment. And this functionality, I guess, is one of the more I think useful features for Cloud Foundry once that comes out. Even that a lot of people, for production accounts, right, they really want that dedicated service instances to be running and not being shared by any of the development resources and things like that, right?
To me, it's like a really exciting balance between giving the developers the on-demand configuration and immediacy of getting a cluster, but yet you still let the operations team be responsible for operating the cluster and updating the software when there's updates to come out. So it's like this really nice balance where, like some of the things I've been seeing recently for other other software in the space, whether it's like Kubernetes or Docker or something like that. A lot of their examples, they show developers deploying their own data services and running those things in containers themselves. And while that might work at some amount of scale, or if you have a really talented developer team, most developers I meet don't really want to be managing a large Cassandra cluster, or something like a big, like a MySQL replicated cluster themselves. That's actually the hard work. Like this thing that came out last week with 2 weeks ago, there was a Redis CVE, and so now if I'm managing that cluster as a developer, I take responsibility for watching all the CVEs and taking care of that. And I really don't want that. I'd rather some centralized operations team do that for me. And so this is this nice balance, having the service brokers provision these things via Bosh on demand, just the size that I want, the configuration that I want, but yet having the operator and the operations team manage that for me is a really great balance.
Yep, valid point. If you look at the pattern of you build it, you run it, that's been popularized. What we're seeing with some of these Docker things is even if you don't build it, you have to run it. Right? It's kind of a headache that no dev wants to deal with. Right? Like, I just want to worry about my code. I don't want to deal with all the other stuff. Just take care of it for me.
Yeah, I think the pattern of consume services whenever you can. So I was headed down to say goodbye to Chris Hoff, who's moving to North Carolina to take a new job at a big bank there. And I was with Adrian Cocroft in his tiny little Tesla Roadster. So if you just imagine me, 6'2", well over 200 pounds, and Adrian in this tiny box of a car. And it was funny, I was talking to Adrian about, if I wasn't doing Cloud Foundry, the one thing I find fascinating is how clogged up banking is, and that banking needs to be written as a cloud-native app. And just getting his perspective is interesting because he spent the time at Netflix. He's like, yeah, I started using Kinesis, and he named off all these Amazon services. And it's really instructive to people that, when he talks about cloud, he's not just talking about VMs on demand. He's always trying to use the highest level of abstraction that he can for his teams to go build things. And that doesn't always mean that you build it all yourself. That actually means that if there is a service out there that has been deployed and is managed for you, that does things in a repeatable, scalable way, you always use that to go build your software.
And now that Rob's here, I can talk about OpenStack.
Wait, before you change topics, I have a completely different position from what y'all are talking about. Maybe not
even better.
But so, and actually, there's a segue in with OpenStack in this, but I think there's a fail pattern for developers who build a developer scale. Say, let's use Cassandra as an example. Oh, I get Cassandra running in a container, and I use that as the target for my application, and it works for me. I have that trademarked, by the way.
Yes.
It works for me on my desktop because I have a one-node Cassandra container, and that's, they test there and they go. And what I think is important is that we actually need to be able to share developers using production type deployments where they actually have the production type problems and challenges as close to the code generation as possible, right? Real security issues, real HA issues, real timing issues. And some of those things, I believe, we can start to surface using containerized workloads where we want the developers to be using more production-like, maybe not full production scale, but more production-like backends for their work, because if they don't have it, then they build crap.
So, Rob, I don't know that we're actually disagreeing. I think you're raising a great point, but it's sort of a different direction, which is to say, when people are talking about focusing on services and that abstraction,
right.
I think that's a good thing. What you're raising is sort of the danger of going blindly into that, which is sort of a traditional distributed systems misthink, if I can coin that phrase, which is that the service is 100% reliable. And it's not, and in fact, it's worse than that. It actually will fail in all sorts of new and unexpected ways that would not possibly be true if you were running in a single node on the same
Right.
system as the app. So I think what you're raising is a really powerful and accurate argument in favor of much more intelligent testing.
It's that, but it's also developers needing to get closer to production style deployments. That if their backends aren't scripted using the same implementation or as close as possible as what the production people are using, then they're going to basically be walking into landmines that
Yeah,
that
you get what
that are
you
totally that would have been totally avoidable if they'd said, "Oh, I better not write my own Cassandra deployment. I should coordinate with the ones that our ops teams are doing and
yeah,
share that code."
you're totally right. I would I call that difference between what you tested with and what gets deployed a fidelity gap. And you
Mm.
always want to narrow your fidelity gaps. You see it in all sorts of places. I saw it a lot in doing network config simulation, where you would expect a certain behavior, but because of bugs and interaction between different vendors or even in different versions of code, what you assumed to be the behavior was not at all the behavior.
Have you written that, or do you have a cross reference? I love that phrase.
Fidelity gap.
Yeah.
I would be surprised if that's new.
Yeah, I mean, me too, but it's very clean. I've used the phrase impedance mismatch in the past, but that's not exactly the same thing.
Yeah, that's a really common one as well, but it feels like fidelity gap sort of captures
It's
it
different.
more.
The bridge, if you want a bridge to OpenStack, I'll give you the exact bridge from fidelity gap
I have a
into
different one,
OpenStack.
but let's hear yours.
So this gives me. I'll do a little bit of history here because this goes back to the Boston Summit, which was the Diablo release, when DevStack was introduced. So my team was demonstrating a fully automated 5-node deployment for OpenStack in Diablo. We actually had the physical gear doing it, completely automated. And the developers wanted to increase the number of people contributing to the project, so they wrote DevStack, which was a single node deployment of OpenStack, which ultimately became the gate for all development tests, still is the gate for development tests for OpenStack. And what has happened since that the widespread use of DevStack as the OpenStack development environment, we've created a tremendous fidelity gap between where people develop OpenStack and where they test it on an hourly basis, and actual production users which never use a single node deployment of OpenStack. It's an anti-pattern. And consequently, we have core capability features for OpenStack that are never tested as part of the gate. Things like live migration and multi-vendor HA, and we've been working towards that by creating federated test clouds. But the premise is fundamentally broken to test a production OpenStack deployment against a single node deployment. What was your example?
Oh, I don't know that I was going to give an example so much as say that they're really you took this in a really interesting direction. I don't want to lose that, but one of the arguments that I've long made that I think have not been understood by folks responsible for OpenStack or using OpenStack is that there's just no way that OpenStack could keep up with the pace of new services coming out of Amazon at the quality that they're coming out of Amazon, right?
I will agree with your statement with the hat tip that people in the OpenStack community would disagree with you.
I'm sure that they would. I have no doubt. But it's sort of the proof is in the pudding on this one, right? In that nobody, OpenStack community aside, nobody can believe how fast Amazon is pushing out new services, and they're good and exciting stuff, right? Lambda is incredible. I'm totally jealous of not having thought of that because it's awesome, right? Uh, so uh, I think it's totally unrealistic to believe that people can keep up with that. But it creates a new problem, and I don't want to go too far down this path, even though people are going to drag me. I want to talk about what you were talking about, and that's that you get locked in by the services, right? And I
Yes.
usually argue against lock-in as a real problem, but uh, to James's example, talking about Adrian being a big service fan, that's the whole point, right? Is that it turns out that just as there is with Bosh, with all these services, all this stuff that you thought was specific to you is undifferentiated heavy lifting, right? It turns out you had no business doing what Kinesis does or doing what Lambda does, right? All these sorts of things, they can just become services. It requires, I think, some care in how they're architected and how they're presented and how they're integrated with all the other infrastructure. And even looking at Lambda, they're still, I think, improving that. But it shows that that stuff actually is platform. And
Yes.
It's sort of the bar for what is platform, where platform is undifferentiated heavy lifting, always going up the stack, right?
So I have an interesting tie into this, Ben. So we've got Phil joining us, which is great because he's part of the Spring Boot community.
Hey.
And hey, what's up, Phil? And with Phil, is doing some amazing stuff with Boot to like make the developer desktop or laptop workstation experience really productive, writing Java Spring software really quickly.
Just
so
so
like what?
James, like you should brag a little bit about Spring Boot. Like we're talking about something that is right now getting 1 million downloads a month. Like
I think it was 1.3 million this last month or something like that.
Just so when Phil comes on the show, a little bit of respect.
Yeah.
I joke that I wrote a script to download 1 million of those.
So where I'm really interested in is where this conversation all kind of collides, where there's this fidelity gap between what you might do on your, like my IDE writing some Spring, I can write a Spring Boot. You've seen these things, like people can write a Spring Boot app in a tweet in under 140 characters. But if I'm doing something a little bit more real, and I'm starting to use now some data services and stuff, what does that experience look like on my developer workstation on the path to rolling it out someplace where does the fidelity, where should that where is it okay for me to have mismatched fidelity, and where is the fidelity?
Do you want to see it? We've just released M1 for 1.3. I could share a demo if you're interested in seeing what it looks like.
Yeah, I think that'd be great.
Okay, bear with me. Alright, can you see that? Can you see my screen?
Yes, yeah, it looks great.
Yeah.
Cool, okay. So I've got, I thought I'd try and write like a little demo app, so I thought I'd try and recreate the one that comes with Lattice.
Awesome.
So this is the little Lattice demo, just running locally. So if I start it up. So in this case, I've just changed the colors and twisted it around a bit. But one of the things that happens with the early versions of Spring Boot is some things work locally and some things don't. So for instance, I can change, say, the CSS, maybe like cut down the font size or something and refresh the browser. That works immediately. Certain other things, like if I change the template, it doesn't work. So cached. So this stuff's cached once at startup, and you have to change a setting if you want to have it update. And for other things like the Java code, it's even more hit and miss as to whether it would work. So what we've been working on is trying to make that development time experience a bit nicer. So we have this new module called Spring Boot DevTools. So the idea is you can throw this into your app, and if I restart this app again, so this time things should work a bit better. So I can change the CSS as before. That should still work. But this time I can also change the templates. So we've changed the settings to things that make sense. So that now works. And we've also gone a little bit further in that we've built in this live reload server. So you can get a plugin for your web browser. You can get one for Chrome and Firefox. And if you click on the plugin button, that attaches to your actual running application. So this time I can change stuff and save it, and the app actually refreshes itself, so I don't have to refresh the browser.
Nice.
Which is like quite a nice little. I was surprised at how much that actually kind of changes your workflow. It kind of saves time. Just that little, not having to go over here, click refresh, and restart the thing. So actually, I developed this app, this afternoon, and that actual process I used, and it made. I was surprised at how much difference it made. And so the other thing we can do now as well is, like, I can change the code as well. So if I change the code, and there's been solutions for this already, but they're normally commercial. Spring's got one, but it's kind of difficult to support. So we try to do something a bit simpler. So, like, if I change the code now, what will happen is my app actually monitors the code and restarts, but because it doesn't have to restart the whole JVM, the actual restart time is much quicker. So that makes that kind of local development experience a little bit nicer.
Hey Phil, is that with live reload or without? I mean,
so that's doing both. So the way that it works is the live reload server stays in the active part of the JVM, and then the app's stopped and restarted, and then the live reload triggers and it reapplies it.
Oh, that's cool. Okay.
So that was quite fun, but one of the guys on the team was talking about how we can take this and make it a bit nicer in the cloud as well. So what I've got here, hopefully this works. I've got a Docker file that's part of this build. So this is just how you'd run this thing in Lattice. So I've got use the Java 8 image, start the particular app, and then start Java, but with some remote debugging enabled. So if I run this app again, but this time in Lattice, so here's one that I've got deployed in Lattice. So normally, I think with Lattice you can punch a hole through it if you want to do Java remote debugging, but it's sometimes a bit of a pain to do. And in Cloud Foundry, you currently can't do that at all. But I think it's coming.
That's
so
right.
This Spring Boot 1.3 ships with this extra thing. So if you go to my run configuration, I can start the same app, but this time point it at a class that we've provided that runs a different application, and then as the argument, I just tell it where I want to connect to. So in this case, I'm going to say I want to connect to the version that's running in Lattice. So if I do that, the app that's running locally is connected to the remote one, and it's provided me with a local Java remote debug server. So now I can actually remote debug and attach through HTTP to the Lattice instance without having to set up any kind of tunneling. So if I refresh Lattice this time, it's going to hit my breakpoint and give me a kind of remote debug, but inside a container or inside a cloud deployment, which is kind of cool. And the other thing that we've done is if I can build this locally. So this would be like the normal workflow for a developer if they're actually pushing to Cloud Foundry, like build it locally and then CF push it. So I've got I've called it real good. So if you're a Salt Pepper fan, you'll get that. If you're a certain age, you'll get that. So CF push, the app name, and then this is the process of like actually pushing that real app to production. And it's from an operational point of view, it's like blinding fast. It's much quicker than going and provisioning a machine or plugging in network cables and stuff. But from a developer experience, it can be a little bit time consuming. And I used to work on a project in VMware where we were trying to port an existing app to like the V1 of Cloud Foundry, and often we'd find this kind of loop, the bit that would kind of eat time. You've got a bug that maybe takes you 5 minutes to fix, but you've got this kind of loop of going round and round to get there, and it can be quite, painful to actually get to the point where it's working. So, still starting up. Almost there.
I think it's like the very simple boot apps are somewhere around 1 minute to go through the staging process and
Yeah.
to the point they're running.
I think it's often it's the Java bit that seems to take the time. The actual starting up of the app isn't too bad, but just getting to the stage where you've built the image, the garden image, and that's the bit that seems to be time consuming. So that's called it real good. Okay, so that's it running on Cloud Foundry. So I can use the same application that I showed you with the Lattice, and I can actually attach to a real Cloud Foundry application. And then this is also going to start up the live reload server, so I can attach this my local browser to my local live reload server, and then this application is monitoring my class path. So if I want to make changes now here locally, like if I change the font size again, this time instead of it updating locally, this application watches it, sees the changes, and then pushes it up to the remote Cloud Foundry application. So this is actually doing kind of live patching, if you like, of a real application. So it's no good for production. Like you wouldn't want to have this app enabled in production, but during development time, you can see the difference there. It's quite quick. If I can change code as well, like
that is really cool. That is so cool.
Like change the uptime or something. If I could type. And again, save it, and it watches it, sees the changed class file, pushes that up to the remote endpoint, and then our local class loader up there recognizes the change and lets you kind of iterate on the app whilst it's remote. Yeah, that's it.
Really nice.
So that's really great, because this is exactly to the point. If you have these great developer experience aspects figured out for doing debugging and hot reloading stuff, then you can actually use something that's high fidelity from the server's point of view, and still have a really nice quick turnaround time on when you're changing code.
Yeah, I mean the way that when I was working on this project before, the way that we'd actually end up working was like trying to do as much as we can locally, because that turnaround speed is the fastest.
Mm-hmm.
But occasionally you're depending on services or just the fact that you're running your app in a different environment, which is like what people were saying earlier, that trips you up. Like we had this was quite it was an app that used to run on your desktop, so certain assumptions that were made there just didn't hold true. So things like we had to do long polling to update the UI, and with V1 Nginx was in front of Cloud Foundry, and that had different timeout values. So just tiny little things like that can really mess you up when it actually comes to deploying your app. And then trying to work out what's going wrong when you're in a different environment is it can be quite difficult. So I think the having empathy for the developers helps it a lot.
I think when you guys blogged about it a couple of days back when 1.3 came out, and I saw the line about this, I haven't been close to this one, so I didn't know what exactly it was. But I think this feature or functionality has been grossly undersold in that one line update that I see in the blog post.
That's exactly what I was thinking. Like, this is the first time I've actually seen it demoed. Do you have a video that someone's going to put together that actually shows people how powerful?
Yeah, well, the 1.3 release was a week late because of various pain, and I think it went out at about 2 in the morning, and I didn't feel like recording a video after that. But I plan to record one probably tomorrow and then push it out on Tuesday. to hopefully get people a bit more interested.
The least you should do is update the blog post and say, this is sick, wait for a video to get posted.
Yeah, I like to undersell things. I mean, there's been technologies like this that are out there before as well, and a lot of them, like the JRebel solution is in some ways better. It's faster to update the stuff, but I think we're seeing with people working on kind of smaller services, hopefully something that's kind of good enough. A second start, whatever is.
Now you're like really understanding. The key to a lot of these things that we see over and over is integration, right? And by being part of this Spring ecosystem, this brings more to the table than you would get from even a more fully featured, purpose-built thing that you bolt onto the side, right? And
yeah, I mean, it's been easier for us because we can make certain assumptions that other tools can't.
Right.
So we know that the way that our apps start up means that we can shut them down and restart them. We know that the way that our libraries load classes, we can make certain assumptions about things, or if we don't, we can fix problems that we find. So in a lot of ways, it's easier for us because we're part of the team that builds the software.
Because you have opinions. That's powerful. Right. I mean, the rest of Spring is opinionated, and you're relying on those opinions to be able to just deliver functionality like this, which in sort of a more general purpose system is really hard to do, and that's why people charge money for it. So the other thing I would point out is this is the first version that has it. So the fact that it's a little behind much more mature products, that shouldn't surprise anyone, right?
Yeah, that's true.
And Phil, this works even without the browser extensions, right? I mean, you guys have done that. The tagging and all that's needed.
The live reload thing's optional. Like if you don't have that plugin, then you have to click on the browser and hit F5. Refresh it.
Gotcha. Okay, okay.
So, yeah, the live reload. It's it's a commercial product, but they give the browser plugins away for free, and the spec is open source, and it's basically a WebSocket server. So we've just written a very small, partial implementation of a WebSocket server that the browser can talk to, and then you just kind of trigger it and say something's changed. So we're kind of thick about how we do it. If anything changes, we just say refresh the page.
Okay. Yeah, I've used it in the past, but just for CSS file changes. But this one takes it one step beyond. Neat. Nice. Is there anything else in 1.3 which is being undersold? Now I'm kind of.
Well, if you listen to him, all of it.
There's some new caching stuff. That's kind of interesting. Lots of support for different cache providers. There is some metrics update that's going in, mainly to support Spring XD. We have some interesting stuff with services, which is kind of cool, but probably not something to talk about on the Cloud Foundry thing because it's really outside of Cloud Foundry. But you can basically, it turns out you can embed a little bash script at the start of a jar file. So we can have Spring Boot apps that you can just run by doing // the name of the app, and then if you symlink them to init.d folders, they act as services. So that's kind of nice if you're not running in a, if you're behind the times and you haven't got a cloud deployment.
Got it. Got it.
Well, I'm glad you came on, Phil. Please keep us up to date on Spring Boot. I just
yeah, often this time conflicts with bedtime for my kids, so I often watch the catch-up session rather than live.
That's
who watches live TV.
That's what we call the Tough Mudder of tech social media. It is an endurance and fitness test. It is not easy.
But if it changes to midnight, as you're talking about, I could probably join more often, but I probably couldn't say anything.
Yeah. I love how as soon as Schaefer needed to adjust me, he's like, well, the whole thing has to change for me now. Fine. Rob, can I ask you a question?
Of course.
Have you worked any more on that Bosh bare metal CPI since you came on before? Because I copied you in that one big financial services information company that really wants it. What can we do to accelerate that? This is sort of a live meeting here.
Just all we need is somebody who wants to collaborate on it.
Okay.
And I'll put people on it. I have been working. Actually, my issue, one of the reasons I jumped in is because Um, I'm trying to figure out how to run Bosh. My challenges are learning Bosh, not the API code integration. And what I'd like to be able to do is figure out how to run Bosh on my desktop, just sort of run it in a test mode. And that wasn't clear to me. It's clear how to target it at stuff. It's not clear for me how to just sort of step through the code and get it working.
Well, you got Dimitri on, and if you want us to buy you a plane ticket and a crash pad for a week or two to come out and hang out with Dimitri and his clan out here, let me know. We'll be happy to hook you up.
If you guys can do that, I wouldn't. It wouldn't be me. I'd send somebody else, but I can. That would make it much simpler. Yeah, totally.
I'll write the check tomorrow. I'll arrange that. Yeah, let's do that.
Okay. Yeah, let's sync up because I have somebody whose specialty right now is actually building the API integrations for these platforms,
Yep.
and we're pumping them out like crazy. It's pretty cool.
Great. Hey, Dimitri, are you interested in someone else worried about all the bare metal stuff? You just call an API and it's like business as usual?
Absolutely. Absolutely.
Cool. Yeah, I have a guy I can put on a plane to San Fran in very short notice if you guys can make it happen.
Yeah, I can. I will.
Just do it.
Hey, Rob, what approach do you guys use? Are you doing that ironic thing, or is it something different?
No, so sorry, I'll back up a second. So my day job is Open Crowbar. So we're commercializing the Open Crowbar core, which just runs bare metal. And so we use Crowbar's API. Basically, we pull a machine out of a pool, and we'll spin up the stem cell. We'll do all the stem cell steps against that machine, prep it, and then the final step is going to be to attach it back into, basically tell Bosh that it's ready. So Bosh asks for a machine with the stem cell, we build it, we hand it back to Bosh, and Bosh keeps going as if it got a VM. And then one of the things that's cool is we just did a Ceph deployment, so we sequence-wise, we can now do the back-end block store. So we could attach a volume to that machine that you had created through the Bosh APIs also. But yeah, the Bosh's APIs do things like get machine, return machine, pretty straightforward. And so attach storage, create storage, pretty straightforward. All these things are not hard at all for us. And I think we have a concrete way to do stem cells. So we wouldn't use the AMI images. We'd actually just build the stem cell. But all pretty straightforward.
Cool.
Yeah. No, it's very simple, very fast. No intermediate pieces. And then the added benefit with the approach is that you can add operational steps that are site specific without breaking the overall workflows. Let me unpack that for a second. The way Crowbar works is it's a directed graph, but it's loosely coupled. So if you have a site that has to do burn-in tests or add in a monitoring agent or do specialized networking changes or they have a disk configuration they want, you can add that into the workflows. They get included in the workflows, but they don't change the way Bosh interacts. So Bosh doesn't have to ask for it; it just automatically shows up as part of the operationalization of the metal. That ends up being the trickiest thing. It's giving a machine to Bosh is not that hard. Doing it in a way that fits within the end person's operational environment can be tricky.
Yeah.
So, but yeah, if you guys are ready, let's move. I've got people who can do it.
No, that's awesome. I promised Justin from Bloomberg we'd work on this for him, and Dimitri's been on the phone with him a couple times, and I think this sounds like less heavy lifting for us, Dimitri. Like it's more business as usual for you. So hopefully that's a good thing if we could try it this way.
Do it. Send some people over.
Let's hook it up.
He'll work on.
I have no problem getting people on planes.
He works until a mem break around 9. He looks at some mems with Sriracha. He'll take a mem break, and then they'll be back at it.
We'll do it. Let's talk in the morning. I'll scramble the jets. We'll get people out there.
No, I've been McKenzie's in Asia, and I was on him. I'm like, hey, what are you doing with Hirschfeld in this? He's over in Asia on a trip over there right now with a bunch of big customers. So this is
Awesome.
what we run into here.
Cool. I was having a conversation about with Sam about something about the same topic. So
Yeah, I mean, I think the whole foundation could really benefit from a bare metal approach for Cloud Foundry. People want it, and I always explain that there's nothing about Cloud Foundry that requires anything other than an automation API. We don't care if it's a virtual machine or anything else underneath the covers, really.
right. I'm listening to the way the market's starting to respond about the way workloads are going and orchestration on this and the type of stuff that Bosh can do. And there's no reason at all anymore to not have it run direct on metal.
Great.
The other thing that's fun about this, moving away from Bosh, is to actually start talking about reference architectures. And one of our guys is starting down the path of actually doing some hardware design. So if you have somebody who wants to talk about that, we can also do that, because I think that we have some really interesting opportunities to do hardware optimization for Cloud Foundry that is different, more cost-effective, maybe more power efficient, and more I/O tuned than what you would get if you were just basically taking virtualized servers that would normally have run virtualization and switching it over. So we're just at the start for that, but I think that's also a part of the story that we need to tell.
Hey Rob, is that at all affiliated with the open compute stuff that Facebook is doing, or is it different?
It would be different. It could be, you could be using very similar form factors. What we're discussing on my team right now is, do you want to have smaller machines with less RAM and no redundant networking? So you could literally use much more dense, a lot smaller machines. So instead of buying 96 gigs of RAM, you could split that across 4 machines, get 4 one-socket or 4 dual-socket machines, put one 10-gig NIC in them instead of dual 10 gigs, and have a much more cost-effective, more distributed workload. There's some really interesting potential cost points on this, where those machines are very effective. I know there's some open compute machines that are more in that line. Frankly, I'm starting to describe what I just described as more like ARM servers. Some of the new 64-bit ARM stuff coming out, hyperdense, sort of shared nothing chassis designs. I mean, I'm not. This probably isn't the right call to discuss it, but we're starting to talk. We're trying to collect the data and have the discussion. I know some people we've talked to believe you should put super big machines at the back end of this and cram as many workloads on top of one machine as you possibly can, and then go for big machines with less density. So I don't know. I'd like to talk about it. Could be a topic for a whole Cloud Foundry After Dark if you want.
No, I think it would somewhat affect our DEA layout, etc., depending on how often we expected these things to go away. I don't know what you think, Bear, but I think it's still a little bit up in the air about how big of DEAs you should optimally use, I guess, or we never really factor economics into it. I guess on Amazon we look at that, but it'd be an interesting conversation.
I know when we looked at the Bosh work, since we would turn machines off when Bosh told us they were being destroyed, you actually could have a very efficient rotation through hardware, and when the system was underutilized, you would turn machines off, cover power, and then actually go through some really nice cycling, so that you have a nice constant refresh cycle for the whole environment. Has some interesting potential.
Just from my own curiosity, like these aren't like these old school Solaris days where people would be like posting pictures like, I haven't rebooted my Solaris image in 1,000 days or something like that, right?
The thing that gets interesting to me is if you had, say, a stem cell change, you could cycle that through the environment, and the more fine-grained your environment is, the faster that it wouldn't necessarily be faster, but the less overall utilization impact you'd have as you cycled through the environment, did an update. Right. There's some really, because you'd get a normal flow pattern day night if you were doing that, where you'd actually turn machines off and cycle them all through the environment, sort of walk your configuration. What I don't know is how well Bosh would take care of fault tolerance within that environment to make sure that you close down machines that weren't didn't have fault zones. Maybe some of the Amazon. I'm trying to think about the API. Dimitri, you'll know it better than me. Does the API account for regions when it makes decisions about scheduling?
I mean, for the software that Bosch installs on the VMs is not necessarily scheduled in any dynamic way, right? It places it to a very specific location, and if that location is gone, it tries to, recreate the VM in that location. It's very deterministic in that sense.
Okay.
But,
I mean, there's ways we could simulate it. There's also things that we can do to do load balancing from the crowbar side, where we would actually make sure that there was the machines were offered in a certain distributed way.
with some of the new features that we're going for first-class availability zones, Bosch might start making some more complicated decisions of where to place stuff and how to balance stuff across different AZs or regions, I guess.
Perfect. Right. This is where we could talk, and the guides and you could talk through how to expose AZs from a physical topology perspective, because you'd get rack level AZs or power level AZs or switch top of rack switch.
Right.
Because there's really fun stuff to put behind this, where you could create really robust infrastructure automatically.
So just out of my own naive curiosity, like, is it considered a best practice to be rebooting these hosts on a schedule, like, so that you at least power cycle them every so often, as opposed to keeping them running for a long time? Like, what's the
so
what
the
amount
big
of time was? Go ahead.
Go ahead. What's the cycle? I think it's going to depend on how fast your infrastructure is bouncing. But I would what I've seen in the past for the big players, if you get say a 1,000 node cluster, you're going to want to cycle every machine in that cluster within probably like a 30-day window. And so 1,000 nodes, if you're going to do it off peak, right, you're going to take down. Trying to do the math really fast, but you could actually do every night. You would be taking down 30 machines? It's a rack, and re-provisioning a rack. So yeah, it's a pretty significant amount of churn. But it's gonna flush out issues. It's gonna keep you more updated from that perspective. You can keep everything on a much faster level. Right, because I'll give you the alternative. The alternative would be if a stem cell change comes out, you might have to flush all of your machines really quickly, and that would be bad. So the idea for the real big sites is that you want to be on a continual refresh cycle, because you don't want to be surprised when it's an emergency, trying to get caught up. You also want to be able to always exercise that muscle, if you'll.
Yeah.
Right. If you want to be able to say, oh, I can turn the environments really quick. So if you had a security patch you wanted to pass through your environment, not that we ever have security issues in the internet, but let's say you needed to do an SSH Heartbleed type issue and cycle all your environment really fast, you'd want to be able to say, all right, turn the knob up to 10 and go. And that's that. Yeah. So the more you're cycling like that, the better odds you have of surviving that.
Cool.
That was. I can't give the names, but I'll give you. There was one of the major early cloud companies that we were working with when I was at Dell, and they actually had a 30 rack design, 10 racks of compute, 10 racks of storage, 10 racks of database capability, and they would they had it had to be 10 racks because every week they would, they had one of the, so there were those 30 racks, 10 racks of each, and they would cycle basically one of those racks every day, and then you could lose a rack in the process, and so they could never be more than 20% down. So they had a rack out, and then they had a potential rack being cycled at any point. And so that required them to have 10 racks of capacity in each major area. It was a bit of an overkill for most people, but it was perfect. That was their design, and I've heard similar things out of other massive infrastructures. Facebook being an example.
Well, here we've just gone from hardware to Spring Boot live code refresh, one in one go. Tell me another community that is as diverse as Cloud Foundry where you can go between those two poles. I've never seen it in my life. That's pretty cool. I'd have to go back to my Sun Microsystems days, which it feels like right now. I'm like, okay, ship Java, let's do this. Cool. Well, Ben, since you're our host, I think we're at a wrap. We're at an hour and a half. Fun.
I'm just here so I don't get fined.
Oh, you're still definitely getting.
Aren't there any secrets this week?
Yeah, that's what I was going to say. Is we're 90 minutes in and still haven't gotten to secrets, which is kind of a new record. So huge thanks to Dimitri, Rob, and Bill for making that possible because there was just so damn much content.
No hand waving.
No.
You know, Ben, I think you should drop the secret. I think you should talk about what we're doing. Spring Boot data services.
Data microservices?
I think you should.
Well, I was thinking that as Philip was talking earlier, that we need to spend some time on sort of the next version of XD, which will be a thin layer on top of the actual real-time processing infrastructure that we'll be bringing to Spring and tightly integrated into Cloud Foundry for sort of the real-time streaming of Spring Cloud. So as easily as people can do scalable cloud-native applications with Spring Cloud, they'll be able to do that for streaming data applications as well. So I'm pretty excited. I think we should get maybe Fisher on here in the near future to talk about that because as excited as I am, I think that it's really fired up the XD team, and I would love to get some of that rubbed off on people here.
Yeah, I think that's a huge secret that we've got is kind of these cloud native microservices coming. It's huge.
Yeah.
Cool. Let's call it a show. And Rob, I'll touch you tomorrow, and maybe go in here.
Yeah, I already kicked off the thread, so let's make it happen.
All right. It's a wrap. Thank you, everybody.